Hello pre-calc students. Today we're doing the even functions for our 5.1 paper homework, and that is so if you can see similar problems done on the right hand side, you can attempt them yourself on the left hand side. So your homework is to watch this video, take notes, pay attention for the right hand side problems, and do them yourself on left hand side problems. For problem number 2, we need to find the sine of theta and the tangent of theta. The cosine of theta is equal to 0.8 and the tangent of theta is less than 0. Alright? So the sine of theta is equal to negative 3/5 or 0.6. And the tangent of theta is equal to negative 3/4 or negative 0.75. And let's explain why this is. Let's draw our coordinate system. With our coordinate system, we will have our angle, which is in quadrant number 4. I'll draw a negative angle. And we have a hypotenuse of 5. Alright. A cosine value, an adjacent value of 4. And then our opposite value is going to be negative 3. Alright. So if the cosine value is the adjacent over the hypotenuse, remember the cosine of theta is the adjacent over the hypotenuse.
Students, if you are not with a coach or a teacher, you need to be outside in front of the building. All students, if you are not with a coach or a teacher, you need to be outside of the building. Thank you.
Unmuting the microphone. So the cosine of theta is equal to the adjacent over the hypotenuse, and the ratio you can get with 0.8 is 4/5. Okay? So that's how I got the 4, and that's how I got the 5. That 0.8 as a fraction is 4/5. Because the cosine of theta is the adjacent over the hypotenuse, this becomes 4/5. Now the negative angle is going to be, that 3 is going to be negative because when the tangent of theta is less than 0, that's going to put us in quadrant 4. So that puts us in quadrant 4. So now that I've drawn the triangle, I can just use my SOHCAHTOA properties to find the sine of theta and the cosine of theta. So the sine of theta is equal to negative 3/5, negative 3/5, opposite over hypotenuse. So that's the opposite side over the hypotenuse. That's going to be equal to negative 3/5. Which is equal to negative 0.6. And the tangent of theta is equal to the opposite side over the adjacent, which is equal to negative 3/4. Negative 3/4, which is equal to negative 0.75. That's negative 0.6, and that's negative 0.75. Now, there's another way I want to look at this, and that is, drawing the triangle is the best way to do it, because if you use your calculator and you mess up your tangent values and you get in the wrong quadrant, you could do this wrong. So that's number 2. Let's do number 4 now. The sine of theta minus pi divided by 2 is 0.54. Find the cosine of negative theta. So here we're going to use our identity. The sine of theta minus pi over 2, that's going to be equal to the negative sine of pi over 2 minus theta. And that's using the identities that we worked on in our 5.1 notes. Okay? So the negative sign of pi over 2 minus theta, using our identity, that is equal to the negative cosine of theta. So again, check your identities on your 5.1 notes that you have to do. And that's going to be equal to negative cosine of theta. So the cosine, negative cosine of theta, that's going to be equal to negative 0.54. All right, so that's the answer to number 4. I'm going to clear annotations. Move on to problem 6. Problem 6, we have 1 minus the cosine squared of theta over 1 minus the sine squared of theta. Now this is going to use the Pythagorean identity. The sine squared of theta plus the cosine squared of theta is equal to 1. So that means 1 minus the cosine squared of theta is equal to the sine squared of theta. And 1 minus the sine squared of theta is equal to the cosine squared of theta. So 1 minus cosine squared of theta, that's equal to the sine squared of theta. 1 minus the sine squared of theta is equal to the cosine squared of theta. And the sine squared of theta over the cosine squared of theta is equal to the tangent squared of theta. For 8, we're going to do the cosine of y times the secant of y. So the cosine of y times the secant of y, the secant can be written as 1 over the cosine, so we can rewrite it as the cosine of y times 1 over cosine of y. That's equal to the cosine of y over the cosine of y. Equal terms on the numerator and denominator cancel out. And so you just have a value that's equal to 1. Alright, so that's 8. I'm going to clear annotations. I'm going to go to problem 10. Here I have tangent of x times the cosine of x. I'm going to turn tangent to sine over cosine. We find the sine of x over the cosine of x times the cosine of x. And I'm going to cancel out my cosine of x's. So that just leaves me with the sine of x left. So that is the sine of x, and that's problem number 10. Clearing annotations. 12 is 2 times the cosine squared of theta minus 2 over the cosine squared of theta minus 2 times the cosine of theta plus 1. And in this case, we will need to factor each expression. So first of all, we can factor our numerator. Let's factor numerator and the denominator. So numerator, we can factor out a 2 out of each term. So we have 2 times the cosine squared of theta minus 1. So that's just factoring it. We're treating the cosine of theta as if it's a variable. And that's over the cosine squared of theta minus 2 times the cosine of theta plus 1. So we need 2 terms that add to negative 2 and multiply to 1, positive 1. That's going to be negative 1 and negative 1. So I can, we get cosine squared of theta, I can factor this into the cosine of theta times the cosine of theta. That's going to be the cosine of theta minus 1 and the cosine of theta minus 1. Now for my next step, I can factor out cosine squared of theta minus 1 as well, because that's a difference of squares. So I'm going to rewrite my numerator as 2 times the cosine of theta plus 1 times the cosine of theta minus 1. And that's because this is in the form, this difference of squares, a squared minus b squared. That's a difference of squares right there. So this is all over cosine of theta minus 1, cosine of theta minus 1. All right, and these cosines are going to cancel out. So what's left is 2 times the cosine of theta plus 1 over the cosine of theta minus 1. And that is our final answer. For number 14, we have a cotangent squared of x minus the cotangent squared of x times the cosine of x, cosine squared of x. And here I see that cotangent squared of x is the greatest common factor between the two terms. So I can factor out a cotangent squared of x and have left over a 1 minus a cosine squared of x. And once again, this is a difference of squares. So when I factored out the cotangent squared of x, I still can do this in the form a squared minus b squared. So here, the square root of a squared is 1. The square root of b squared is cosine of x, so that this can be 1 plus the cosine of x, 1 minus the cosine of x. But this doesn't look completely simplified to me. So I can rewrite, so even though this can be factored in the following way, there's an even more simple way to get it. We can get this simplified even more than we have it right now. And that's to not only factor it, but also use our Pythagorean identity. All right? So we can take 1 minus cosine squared of x, use our Pythagorean identity, to make this term also equal to the sine squared of x. So the cotangent squared of x times the sine squared of x. Look at your Pythagorean identity to see how we can get 1 minus cosine squared of x is the sine squared of x. The cotangent squared of x is equal to the sine squared of x over the cosine squared of x. The cosine squared of x over the sine squared of x, because cotangent is cosine over sine. So the cosine squared of x over the sine squared of x. That's because cotangent is adjacent cosine over opposite sine. The sine squared of x will cancel out, and we are just left with the cosine squared of x as our final answer. All right. So that's the answer to 14. I am going to clear annotations and we can move on. (16) The tangent of x times the cotangent of x minus the cosine squared of x. So here, I have the tangent of x times the cotangent of x, all right? So tangent times cotangent. So I'm going to write tangent as the sine of x over the cosine of x, and the cotangent of x as the cosine of x over the sine of x, all minus the cosine squared of x. And notice the sine of x's are going to cancel out, and the cosine of x is going to cancel out. And when everything cancels out, all you have left is a 1. So the big 1 minus the cosine squared of x. Let's remember our Pythagorean identity, which is that the sine squared of x plus the cosine squared of x is equal to 1. So 1 minus the cosine squared of x, this is going to be equal to the sine squared of x. And that is our answer to our trig identity. Clearing annotations. For 18, the sine of theta over 1 minus the cosine of theta. All right, we're going to multiply each expression by the fraction and simplify. So here, we're going to have the sine of theta over 1 minus the cosine of theta, and we multiply by 1 plus the cosine of theta over 1 plus the cosine of theta. All right? So we have, let's look at the numerator. In the numerator, we're multiplying the sine of theta times 1 plus the cosine of theta. That's going to give us the sine of theta times 1 plus the cosine of theta. The denominator is going to be 1 minus the cosine of theta times 1 plus the cosine of theta. So we can FOIL it out or see that this is a difference of squares. This is in the form a minus b, a plus b. So this could be reverse factored into a squared minus b squared. This reverse factors into 1 minus the cosine squared of theta. All right, so 1 minus the cosine squared of theta is going to be equal to the sine squared of theta using our Pythagorean identities. So we have the sine of theta times 1 plus the cosine of theta over the sine squared of theta. And remember, the sine squared of theta is equal to the sine of theta times the sine of theta. So we can actually cancel out one of these sine of thetas, and we can cancel out that squared. So now, if we think of that sine squared of theta as the sine of theta times the sine of theta, one of them will cancel out. So now we have 1 plus the cosine of theta over the sine of theta. So we have 1 plus the cosine of theta over the sine of theta. And at this point, I don't think there's any need to really simplify anymore. The one thing is you could rewrite this as 1 over the sine of theta plus the cosine of theta over the sine of theta, and that would give you the cosecant of theta plus the cotangent of theta, but that's about as simplified as these terms. So if you come up with either of these, that would be acceptable. All right. Clear annotations? Problems 19 through 26, we have to write each expression in factored form as an algebraic expression. So for 20, we'd have 1 minus 2 times the cosine of x plus the cosine squared of x. All right? So we have 1 minus the cosine of x squared. All right? So we have, let's rewrite this to figure out how we get this. We can rewrite this term in order as the cosine squared of x minus 2 times the cosine of x minus 1, or plus 1. So we need two terms that add to 1 and multiply to 1 and add to negative 2. So we add to this value and multiply to this value. And our variable is the cosine of x. This is going to be the cosine of x. All right, adding to negative 2, multiplying to 1, that's going to be minus 1. And the cosine of x minus 1. All right, this is going to be the cosine of x minus 1 squared. So that's 20. We look at 22. We have the cosine of x minus 2 sine of x, sine squared of x plus 1. We can rearrange this as negative 2 sine squared of x plus 1. So here I can rewrite this as the cosine of x minus, here I can factor out a 2. Alright, and when I factor out the 2, I can always rewrite the sine squared of x. That's going to be equal to 1 minus the cosine squared of x. And that allows me to rewrite sine squared of x and using the Pythagorean identity. So 2 times 1 minus the cosine squared of x plus 1. Alright, and at that point, let me distribute the 2. So we'll have the cosine of x minus 2 minus 2 times the cosine squared of x plus 1. Just make sure all terms are equal. So I'll have the cosine of x. Alright, add 2 to each side. Sorry, combine the negative 2 and the positive 1. So I have the cosine of x. And when I multiply the negative 2 by the negative cosine of x, it's actually going to be a plus 2 cosine squared of x. I realize negative 2 times negative cosine of x is positive 2 cosine of x. So I have cosine of x plus 2 cosine squared of x minus 1. Alright, so I'll rewrite it in order. 2 times the cosine squared of x plus the cosine of x minus 1. Now I just factor it. Has to multiply to negative 1 and add to 1, but I have a coefficient of 2. So this will factor with terms 2 times the cosine of x and the cosine of x. And 2 terms that multiply to negative 1, and I'm going to add to positive 1. Okay, and so that's going to be cosine of x plus 1 and 2 cosine of x minus 1. The reason why I do that is that 1 times 2 cosine of x is 2 cosine of x, and negative 1 times cosine of x is negative cosine of x, and 2 cosine of x minus cosine of x is just 1 cosine of x. So that makes this term work. Multiplying the last 2 terms make the third term work. Multiplying the first 2 terms make the first term work. So that's problem 22, factored out completely. Let's go to problem 24 after we clear annotations. Problem number 24, we have the sine squared of x over 1 plus the cosine of x. This is going to be 1 sine squared of x. We can rewrite this as 1 minus the cosine squared of x over 1 plus the cosine of x. Alright, and now we can make sure we factor it. So 1 minus the cosine squared of x, this is a difference of squares. So we can factor this into 1 plus the cosine of x, 1 minus the cosine of x, difference of squares, we're factoring it, over 1 plus the cosine of x. Factor each term out, and we have 1 minus the cosine of x as our final term. That's 24. Clearing annotations. For problem 26, we have 2 times the sine squared of x plus 3 times the sine of x plus 1. And now this is a classic factoring problem. So in order to get 2 times the sine squared of x, we'll need have 2 sine of x and the sine of x. And we need 2 terms that multiply to 1. And here I can see this 3 is positive, so nothing's adding to positive 3 if both terms are negative. So that will just be 2 sine of x plus 1 and the sine of x plus 1. Group it. My thought process here is I need a 2 sine of x and a sine of x to multiply to 2 sine of x squared. 2 sine squared of x in the first term. And in order to multiply to 1 in the second term, that's either going to be plus positive 1 and positive 1, or negative 1 and negative 1. But it can't be negative 1 and negative 1 because I need to have a positive number for my middle term. And there's no way you're adding 2 negative numbers to be able to factor that out. So that's problem number 26. Problem number 28. Are the square root of the tangent of x times the sine of x minus the tangent of x. Alright, so let me rewrite this as first of all, let me break down the instructions for you first to show you what I'm doing. You find the solutions to the equation on an interval from 0 to 2 pi. Alright, so I'm going to rewrite this as the tangent of x, factoring out a tangent of x. So I'm going to factor out a tangent of x. And what's going to be left when I factor it out is the root 2 times the sine of x minus 1. And that's going to be equal to 0. Alright, and so now I have 2 terms. I have my tangent of x term, and I have my root 2 times the sine of x minus 1 is my second term. And make sure that both terms, find the values of x to make both terms 0. So when is the tangent of x 0? Using our unit circle. So it's very important that we know the unit circle. The tangent of x is 0 when x is equal to 0 and pi. Now, there are other angles that make the tangent of x 0, but those are not in between 0 and 2 pi. There are other angles coterminal with 0 and pi. 2 pi, right? 5 pi, 3 pi. So those are values that would be coterminal with these values, but it's only between 0 inclusive and 2 pi not inclusive. So our only values here are 0 and pi. So now let's solve for our other equation. Root 2 times the sine of x minus 1 has to be equal to 0. Root 2 times the sine of x minus 1 is equal to 0, which means that root 2 times the sine of x is equal to 1 over root 2. Oh, I'm sorry. I overstepped myself. Root 2 times the sine of x is just equal to 1.
Yep.
And then I divide each side by root 2. And you need to find all values where the sine of x is equal to 1 over the square root of 2. And this is where knowing my unit circle values are really important, because you know right away when is the sine of x equal to 1 over root 2, or multiply each side by root 2 over root 2, because we sometimes don't like rationals in the denominator. The sine of x is equal to root 2 over 2. Root 2 over 2. That's the sine of x equal to root 2 over 2. Now, when is the sine of x equal to root 2 over 2? What angles? Well, those angles are going to be when x equals pi over 4 and 3 pi over 4. Let me silence my phone. Alright, so I have angles at 0, pi over 4, 3 pi over 4, and pi. So I'm going to clear annotations. But those are my values. You need to use algebraically find your trig functions, isolate the trig functions, then know your unit circle values. That's for 28. All right, let's go to 30. Sine squared of x minus 2 sine of x is equal to 0. So I'm going to factor out. I have the greatest common factor of the sine of x for each term. So now I can factor out the sine of x as one term, and then the sine of x minus 2 is equal to the next term. All right, and that's all equal to 0. So when is the sine of x equal to 0? This is the first term. This is the second term. Well, the sine of x is equal to 0 when, let's look at our unit circle values. The sine of x is 0. Look at a unit circle. That's when x would be equal to 0 and pi. Remember, this comes from the unit circle, so you need to know your unit circle values. C, that's a C, that's an L. It comes from the unit circle. Now, the second one is we'll have values that don't exist. When the sine of x minus 2 equals 0, that means we need to find values when the sine of x is equal to 2. Well, there's no values when the sine of x equals to 2. The highest values for the sine of x by itself can only be equal to 1. And so these values, there's no values of x do not exist. They do not exist. So I can say D and E. Some more answers here to make this equation true is when x equals 0 and when x equals pi. So answer here are 0 and pi. And these are the solutions to problem number 30.
So wait, why did this?
Because the reason why so let's say the sine of x. So why can the sine of x not equal 2? Because when we look at our unit circle, all right, the sine value is the y coordinate on the unit circle. And the highest sine value you can get, this is the point with the high sine value, that's at 0, 1. Because each point on the unit circle is the cosine of x times the sine of x. Those are the x coordinates, that's the y coordinate.
So we got 2.
X coordinate and the y coordinate. So the highest y coordinate of the sine of x is 1. Also, if you look at your trig graph, you start at the middle, but your highest sine value is going to be at the sign value is equal to 1. That's the highest sign value on the trig graph. So that's why you cannot have a sign value that's equal to 2.
Because it can't go past 1.
Yeah, it can't go past 1.
Yeah.
All right. And so now we just have oh,
32.
whoops. Let me dock right, and I believe we are what happened to okay, for some reason that didn't go away. I have one more problem before my video's over. Download. So technical difficulties here. You can just fast forward through this part. But for 32, we have 4 times the cosine squared of x minus 4 times the cosine of x plus 1. And we're going to factor this puppy out. All right? So we have, what we can see here is that we can factor 4 times the cosine squared of x. We can break this into 2 terms. 2 times the cosine of x and 2 times the cosine of x. I need 2 terms that multiply to 1, and the middle term is going to be negative. So that means our terms right here have to be minus 1 and minus 1.
So
Let's prove that these are the factors.
won't that be 2 cos x minus 1 squared?
Well, let's FOIL it out. 2 cosine of x times 2 cosine of x is 4 cosine squared of x. 2 cosine of x times negative 1 is negative 2 cosine of x. Negative 1 times 2 cosine of x is negative 2 cosine of x. Negative 1 times negative 1 is positive 1. So we're ultimately going to have 4 cosine squared of x minus 4 cosine of x plus 1. So this is a correct factorization. So we do have 2 times the cosine of x minus 1 squared is equal to 0. All right, which means that we did take the square root of each side. The square root of 0 is 0, so we have 2 times the cosine of x minus 1 is equal to 0, which means that next step, 2 times the cosine of x, add 1 to each side, is equal to 1. Divide each side by 2. The cosine of x is equal to 1/2. And if we know our unit circle values, the cosine of x is equal to 1/2 at pi over 3 and 5 pi over 3. And these are just come from the unit circle. If you know your unit circle table values, you can see that the cosine of x is equal to 1/2 at pi over 3 and 5 pi over 3. So those are the answers. Pi over 3, 5 pi over 3. That's the video. Hopefully that helps you out with your 5.1 video. All right. Have a great day.